Eric Burgess here, and we've been asked to verify 1 plus sine theta over 1 minus sine theta minus 1 minus sine theta over 1 plus sine theta equals 4 tangent theta secant theta. So it's kind of a lot, and there's a couple directions we could go. This 4 kind of suggests that there could potentially be a double angle identity. It doesn't have to be there, but I wouldn't be surprised if one pops up. So my first inclination is let's get everything over here onto the same fraction because it's kind of confusing with them being all separate. I'm going to start by just writing the justifications and just going straight for the proof. So we're going to do, we're going to get a lowest common denominator. So to do that, right, we're going to take 1 plus sine theta. And this, in order for this fraction to have the same denominator, it has to be multiplied by this. So that's going to be times 1 plus sine theta. And then we've got this minus sign. And then we've got our top quantity here, 1 minus sine theta times what it's missing. And this has a 1 plus sine theta, so it needs a 1 minus sine theta times 1 minus sine theta. And this whole thing is over the two things we multiplied by, this and this. So it's going to be 1 minus sine theta times 1 plus sine theta. And we are trying to verify that this is equal to 4 tangent theta secant theta. And we haven't touched this side at all. So far we have not done anything illegal. We've stayed completely within the bounds of what we're trying to show. So the next logical thing would be to multiply, distribute, however you want to say it. So this top one, right, is a special factor case because it's the same thing times itself twice. It's binomial. So we're going to get 1 squared, which is just 1, plus 2ab. If you remember a plus b squared, I'm referencing this, is equal to a squared plus 2ab plus b squared. This is the formula, and if it's a minus, just change this middle one to a minus. That's the only difference. So we're going to have 1 plus 2 sine theta plus sine squared theta. And then we've got minus. And then over here we've got, again, the same thing, only there's a minus here. So we'd make the middle one minus. So we'll have 1. And then we've got minus 2 sine theta plus sine squared theta. And we don't need this much anymore. Now we've got the bottom to deal with, which will be 1 times 1 is 1. And then we have a minus sine theta, because it's minus sine theta times 1, times a positive sine theta. That's going to cancel out to 0. We're going to be left with a minus sine squared theta when we multiply the two end terms. And that's what we get. And we're claiming, well, we're trying to show or verify that this is equivalent to tangent theta secant theta times 4. And looking at this, there's a couple ways we could go. So first, let's simplify first. Simplify. Or combine like terms. That would be a better justification. I'm just going to leave it as simplify. But this is going to go away with this because that's a minus now. This is going to become a positive. Pay attention to that. And this is going to be a negative, so this will cancel with that. Because we have to distribute this negative in, right? So don't forget about that negative. And we're going to get 4 sine theta. So this appears to be where the 4 comes from. So it looks like we may not need a double angle identity. Over 1 minus sine theta. Well, let's go ahead and do two things here. We can use a Pythagorean identity at the same time. So cosine squared plus sine squared theta is equal to 1. 1 minus sine squared theta is therefore equal to cosine theta, cosine squared theta. And I've shown that basic proof several times in previous problems. So if you're struggling with that one, I suggest going and looking at some simpler problems. We got 4 tangent theta, secant theta. All right, still have not touched the other side, so we're still good to go. And looking at this, well, we can get to this just by splitting the sine and the cosine up. So let's go ahead and I'll write that out. Split fraction. And what I mean by that is we're going to pop the 4 out to the front. We're going to have a sine theta. And then we're going to have a cosine theta. And then I'm going to multiply by 1 over cosine theta. So all I did was split the fraction apart. I just took the cosine squared and I split it apart so that it becomes really apparent what our next step will be. Secant theta. And then all we need to do now is use definition. I'm just going to write definition def of secant and tangent. Technically, it's the reciprocal identity. You could write that too, or whatever you want. This is going to be 4 tangent theta, secant theta. And this is equal to 4 tangent theta, secant theta. And by identity, they're the exact same thing on both sides of the equal sign. So we have verified that this is indeed the case. And that is what you would do. So there's kind of a gross section here where, you know, we have to multiply everything out, which is, you know, always is a little frustrating when things get longer before they get smaller. But, you know, you got to do what you got to do. And we were able to show it. And it didn't wind up being all that long. And there were no scary double angle stuff or half angle stuff that we even had to worry about. If you have any questions about this, feel free to drop a comment, subscribe, and hit that bell icon for future videos and problems, and we'll catch you in the next problem.